Okay, in this segment we're going to go through Chapter 5 briefly. At this point, none of this shouldn't be a big surprise in any of these things, but we want to go through it quickly. So obviously branching, if-else is one of the three biggest things you need to know along with arrays and loops. You can't do much in a programmer if you don't know how to do an if statement. So if-else means just conditions, right? If some condition, some expression, if that is true, it will run that block statement. If you provide an else statement, it will run that if it is false. If you write an if statement with no else statement, then if the condition is true, it will run. Otherwise, it will not do anything or continue to the next bit of your program. So, car insurance prices. So we have these price less than 25, price 25 and up. And you have these constants here. If your user age is less than 25, now notice we have a curly brace here. I don't like to do that, it makes it hard to read. I like to put my curly braces one line below, but whatever. As long as you put your block statements inside of curly braces, you will never have to worry about having mismatched if-else statements. Always put, even if it's one line, put it in a set of curly braces. So everything inside the braces will run if this expression is true. So if the user age is less than 25, insurance price is the price that's less than 25. And print executed the first branch. This is just so you can see what's going on. Else, 25 and up. So remember, this is less than, but not equal to. Okay. Now, the annual price is going to print out regardless of which one of these runs, because it is outside of all blocks for the if statement. This is just assigning and then printing which one ran, so you know what happened. Okay. So again, if one way, you go over here. If the other way, you come down below. Statement can be read without an else, so it can just have an if we want just an if. Where's the final values, participation. Challenge activity. Write an expression that will cause the following code to print 18 or less if the value of user age is 18 or less. So, we have a variable called user age. If that is less than, we have two ways of doing it, less than or equal to 18, print 18 or less. The other option would be to do less than 19. Either way would work. To make it more obvious that we're cutting up at 18, we're going to say less than or equal to 18. Write an if-else statement for the following. If user tickets is less than 5, execute num tickets equals 1. Else execute num tickets equals user tickets. So if user tickets less than 5, not less than or equal to, but less than, then num tickets equals 1. Else num tickets equals user tickets. Alright, 5.2 relational inequality operations. So A is less than B, A is greater than B, A is greater than or equal to, less than, greater than or equal to, less than or equal to. A equals B, A is not equal. Explanation means not, double equals is equals. That's checking equality. Make sure you're careful not to do an assignment statement. A equals B is not a Boolean true-false expression, it's just an assignment. Okay. Program prints 0 if the user enters 0, else prints non-zero. Modify the program to print non-negative if the user enters 0 or greater, else print negative. So it's just not print enter number, get the number. If user none equals 0, print 0, else print non-zero. Now we need to modify this to print non-negative if the user enters greater or 0, else print negative. So we're just going to change the else to negative. And here we're going to print non-negative if they print greater than or equal to 0. Write an expression that will print $1 or more if the value of num cents is at least $1, at least 100. If num cents is more than 9, write $1 or more. So, got a variable called num cents, which has been initialized as 0. Num cents is then assigned a value of 109. If num cents is greater than or equal to 100, print $1 or more. Because it is inclusive, at least $1. Okay? Write an expression that will print even if the value is an even number. This one's a little tricky. So how do I know if a number is even? I take user num if user num divided by 2 equals 0, that is, there's no remainder, print even. Oh, my mistake. If there is no remainder, wrong symbol. One way of doing it. Or if division of 2 does not equal 0, that is safe. So we can use this, which checks the remainder equals 0. If the remainder is 0, and I divide by 2, it's an even number. If the division by 2 does not equal 0, see if that works. So I wouldn't write, there are ways to write them sort of long. You want to avoid negations if at all possible, because they're hard to debug and figure out. So you want to stick with what's easiest to do. And anytime you're doing a remainder, well, we could monkey with this and get it to work. The easiest thing to do is just check the remainder and write it like that. If you type the code and fix any errors, the code should check if user num is 2. User num, that needs to be a double equals. Print num is 2, print num is not 2. Otherwise I'm assigning it. Write an if-else statement that checks patron age. If 55 or greater, so greater than or equal to 55, print senior citizen. Otherwise print not senior citizen. And with a new line, so that's going to be means a print ln statement. Now, multiple if-else branches. I can do if, else if, else if, else if, else. So if num years equals 1, if num years equals 10, if num years equals 25, if num years equals 50, different things. Now, be very careful. First off, only one branch will execute. As soon as it finds a true statement, it is done. So you need to make sure that you write this in the correct order. Generally, if it's going like numbers, lowest to highest. Because if my value was, let's say, 25, and I wrote this line first, if these were not straight up equal signs, let's say if num years is, less than or equal to 5, print whatever, less than or equal to 10, almost a decade. But if we wrote these out of order and put the 50 at the top, and our answer was 10, and we said less than or equal to 50, well, 10 is less than or equal to 50, so it would have printed something like your golden anniversary. So the order in which you put these, very important. And also remember, again, it's only one of them is going to run. As soon as a true statement is found, it's going to execute and skip all the rest of them. Alright, I can also nest if statements. I can have an if statement inside of an if statement if I need to have multiple choices inside of there. Alright, logical operators. And or, and not. And means it is and evaluates to true if both of those are true. Or evaluates to true if one is true. Not evaluates to true when it is false. So if age is 19 and days is 7, then age is greater than 16, that's true, and age is less than 25 is also true. So true and true, the entire thing is true. That's how you will evaluate these. Now, if I have a method, it's called a predicate method, or a Boolean type, that is a true or false statement. It is considered improper code to write it as a equality statement. You can, and if it makes it easier at first, then by all means please do, until you get used to it. But, for instance, if I have boolean is done equals false, if, actually that's back, we make it harder. Boolean done. If done, exit and move on. I don't know, whatever. If we're done doing, do stuff here, then check. If I'm done, if I've triggered this flag, now you can say equals true. And that's easier to read, but not as good programming style. Because this already is true. So you're going to say if true equals true, continue. The expression, so you write those at first, but try to get in the habit of just leaving them as so. Okay. If done, now in this case it's if false, boom, kick out. If true, continue and move through. Boolean data types are either true or false. So we've got Boolean is negative. It currently equals false. So if is large equals true, and is negative equals true, print large negative number. Else if is large and not negative, so if is negative is false, not false is true. So then I'm going to print large positive number. Now let's print small number. Write code to assign true to is teenager if kid age is 13 to 19 inclusive. Alright. So I have is if kid age. Now I can't write something like this. This is math. 13 is greater than or equal to kid age, which is less than or equal to 19. That's mathematics. They can't do that sort of an assignment. You have to do one at a time. So if 13 is less than or equal to kid age, and kid age is less than or equal to 19. Actually, right? So if kid age 13 is greater than or equal to, nope, that's right, so less than or equal to kid age, and my kid age is less than or equal to 19. Now to make sure that these evaluate properly, I'm trying to remember what the order of which one comes first. Put them in parentheses. I'll force it to check this first, and then this first, and then check them together. So if that's true, is teenager equals true. Otherwise it stays false. Write an if-else statement to describe an object. Print balloon if is balloon is true and is red is false. Print red balloon if is balloon is true. Print not a balloon otherwise. Alright. So if is balloon and is red, those are both true. Balloon. Else if is balloon and not strings comparisons. Strings are objects, which means that I can't use double equals because that just checks whether or not the object references are the same, not necessarily in the same place in the computer memory, which is not a check we are ever going to make. Okay. So apple and apple, those are the same. Apple and apples are not the same because there's an S. Apple pie, 2 exclamation marks, apple pie, 2 exclamation marks. Apple apple, case matters. Okay. I cannot use double equals. Alright, I can only use a method that checks if they're the same. So if string 1 dot equals apples, if string 1 is the string apples with a capital A, and string 2 is the string apples with lowercase a, then string 1 equals apples is false. No, oops, sorry, not string 2. So if we equal an actual string, yes. String 1 equals string 2, well, string 2 is apples, so that is false. Alright, string 2, now here's where the not happens last. So string 2, which is apples, equals oranges, that's false. Then I negate it, becomes a true statement. Alright, this is a terrible way to compare strings. Okay. Strings are compared relationally, less than or greater than, most sorting words alphabetically. For example, banana comes before orange, so banana is less than orange. That is to say a value less than 0. The compare to returns the actual value for you if you're curious as to how to work. We will use compare to a lot in the future. Complete the code by comparing string variables my name and your name. Start with my name. Okay. So if str1, oops, if my name dot compare to your name is greater than 0, print my name. Programmer can compare strings while ignoring case using equals ignore case. Write an if-else statement that prints goodbye if string user string is quit. If user string equals ignore case quit system out print ln goodbye else system out print ln hello. Do not put a semicolon at the end of your if statement. And match up the number of quotation marks. Okay. String access operations. A string is a sequence of characters in memory. Each string character has a position called an index. It starts with 0, not with 1. Char at or character at will give you the character at a particular place. So in this case, user word, character at 3, user word, enter word with 5 letters, whatever it is. Give me the index 3, character at index 3, which is actually the 4th letter. Okay, so you can see scrambled, so 3 would be 0, 1, 2, 3. The R is the 3rd index. That's why R is the first in the scrambled ones. Very important string methods. Length is empty, not so much. Length, you will use it a lot. Index of, you will use that a lot. And substring. 3 of the most important string methods, not including compare to and dot equals. Right. You get an array out of bounds by trying to go off the end of an array. Very common error. So for instance, if I try to get character at 3, Amy, is anything after that's going to go too far, because Amy is 0, 1, 2, 3. So if I try to go too far, let's get a character at index of 3, it's not going to work. String modify operations. Concat is to stick two together, but you can also just shorthand it and use the plus symbol like we've already been doing. Lots of coding bats with those. Replace either strings or characters. We've already worked on that with the Mississippi. This concatenates the two together. And this, it doesn't, you need to store it somewhere. This is shorthand. I wouldn't recommend doing it. Or take string 1, add string 2 to it, and string it, and save it back. Combining strings. Retype and correct the code provided to combine two strings separated by a space. This should be super easy. String ID, print secret ID. So secret ID equals secret ID plus a space plus last name. Now, you could also run the concat method. Secret ID concat space char. Secret ID concat last name. See what happens. Combining strings. ID concat. String cannot be applied to a character. So, right, because this is a different type. So this one's not going to work. Can't concat character. However, I can concat space and a last name. This is why I don't usually use concat. Just do it by hand. Not worth debugging all of that. I apologize. Modify the second verse below the name game, aka the banana song, by replacing name with username, but without the first letter. So if username Katie, the program prints banana fana fo fady. The song verse may change, which is banana fana fo may or apple fana. So we have to chop off your name. So username equals username substring of 1. Go from first index, not 0, and go to the end, and put it together. So second verse equals second verse plus username, because I already chopped off. Alright. Your output banana name 80. Second verse already has name in it. I'm going to chop that off. So, second verse equals second verse substring. In this case, I need to chop off what we want to keep the exclamation mark. So we'll just, that's easy to fix, plus an exclamation point at the end. So substring from 0 up to, but not including that, which is the length. We don't want to hard code a number because that could be bad. The length minus 1, 2, 3, 4, 5, 6, 7. So let's see if that works. There we go. Oh, testing Katie and ending with explanation. Wants it to be a little better than that. to substring just the middle part out. So in this case, do not override it. So string beginning equals that. String end equals second verse substring. Let's go to second verse length. Because the ending could change, so it's always going to be the same from the beginning. No, let's see if we can make this completely all fun and games here. So int exclamation equals second verse dot index of exclamation point. So go up to, let's see, so the beginning needs to go from 0 to the 4, so into x minus 6, and this is go from the end, from x to the end. So second verse now becomes beginning plus username plus end. See if we did our math right. There we go. So the reason we can put this hard code number in is because we know this is always 6 characters long. But otherwise we want to use things like the first index of an exclamation point to make it as flexible as possible. Character operations, is letter, is digit, is white space, 2 uppercase, 2 lowercase, convenient ones. Nothing particularly hard there. Floating point comparison. This is an extremely important section because since decimals are not quite, if you just use doubles, they're not quite accurately represented at the fractional level. You're going to need to test if they are close enough, because as far as we are concerned, 0.07, if 0.069999999999999999 that is 0.7 for all intents and purposes. But if you were to check that against 0.699999999999999999956, the computer would say, oh, those aren't the same. So just using the straight up double equals is dangerous. And it's a common, tricky AP question. So you're going to check whether or not they're close enough. That is to say, to some arbitrary number of decimal points. Are they close enough for our work? Now, if you're doing some serious mathematical calculations and you need them to be as precise as possible, there are classes, not primitive types, that will allow you to do numbers in a much more precise level. However, for us, just know that if you're using doubles, you need to compare if they're close enough. Okay? For us, we're going to say if they're within 5 decimal places of being the same, that is to say, the tens, hundreds, thousands, they are the same to the 10,000th decimal. We are going to say that they are the same number. Alright, so the absolute value and of those two. Now the difference threshold is called epsilon. It's just one that is picked. The epsilon's value depends on the program's expected values, but 0.0001 is your common epsilon value. So this is not what you want. Alright? Check if they are close enough. Go through this one. Our next question will cause a code to print equal if the value of sensor reading is close enough to target value. So, not a bad idea. Oh, my solution goes here. That would, in your class, public final epsilon equals 0.001. Then it's easy for somebody to come back and through. Then you're going to say something like, you know, if we had something like double x equals, 7 divided by do some comparison between the two. Double y equals 7 divided by 5.50. Okay. We just said if x equals y, now these should not be the exact same, but if they were, and then if we were like double them and stuff, that's not going to work. So if absolute value x minus y is less than epsilon, then I know they're close enough to be considered the same. Alright, so equal to sensor region is close enough to target value. So if sensor math and absolute value, sensor reading minus target value is less than or equal to 0.0001, say they're close enough. Okay. And 511, short circuit evaluation. Logical operator operates from left to right. Short circuit skips the rest as soon as you trigger something that's not going to work. So if I have this big giant if statement, and as soon as I hit the first false, I know it's false, and I'm done. I don't have to read the rest of them. So operand 1 and 2. If I get true and whatever, I have to keep reading, because this one could be false and stop. However, if the first one is false, boom, I'm done. I don't have to check operand 2. It doesn't matter. Okay. Now this one, as soon as I see a true on an OR statement, I'm good, because as long as one of them is true, it is true. If I see a false on an OR statement, I then have to check the other one. So the short circuit evaluation. So if what value of x results in short circuit? So true and true. So if x is 6, as soon as x is a value greater than 4, this whole thing is false and I'm done. Okay. So that is a brief overview of if statements in chapter 5, but you do need to pay attention particularly to the dangling else problem. It's a common problem that they let this slip in the multiple choice questions. If I have more than one if and else, if I have a nested if statement, the else goes with the nearest if unless I tell it otherwise. So if blah 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 blah, if blah 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 blah. Now, this is what I want it to do. So I have an if statement. If that is true, I come in and I do this other if statement. If the first one is false, I want to run my else statement. However, remember that an if statement, the first line will always run. I don't have to technically put it in brackets, but this is why brackets help you. If I didn't put this in brackets, then even though this is what I meant, the computer says these two are closest together. They go together because there's no curly braces implying to tell me that this is a block statement here, and this if is independent and runs by itself. So dangling else's are when there's an else statement that gets erroneously tagged to an if. So the way as it's written out, if this is a false statement, it skips everything and comes down here and runs at this point. The computer says these two are closest together, they go together. So to prevent that, I always put curly braces around. Now if this if is false, it will run here. So dangling else, be very careful of those.